This is lesson 2.2, linear relations and functions. So let's recap with some vocab that should be review for most of you. Linear relation is a relation that has a straight line graph, and then a non-linear relation is a relation that does not have a straight line graph. Imagine that. So, linear equation, an equation that only uses addition, subtraction, multiplication of a variable. By a constant. Variables are letter, constant is our number. So let's take a look at a couple of examples here and then some non-examples. So we're looking for a linear equation, an equation that's going to form that line that we want. So some examples would be 4x plus 5y equals 16. X equals 10. That would be a vertical line, or y equals 1/2 x. Some non-examples would be 2x plus 6y squared equals -25. So we can't have anything squared in there. Y equals the square root of x plus 2. We can't have a square root and it be linear. And then y equals 1/x. X cannot be in the denominator spot. You can't divide by your variable. So a linear function, if you've got some room there, we might have to go underneath. But the definition of a linear function is a function with ordered pairs that satisfy a linear equation. And make that small there. So any linear function can be written in the form of f of x, which we know is the same thing as y. It just means function of some number that we could plug in for x equaling mx plus b. M meaning our slope, b meaning our y-intercept. So let's go ahead and just identify on these next few whether or not they're a linear function and then explaining why. So this first one, g of x is equal to 2x minus 5, and it's a yes. Why is it a yes? Because we have an m, meaning a slope of 2, and then we have an intercept of -5. So it is in that format that we talked about up above there. The next one is a no, and the reason being is because x has an exponent other than 1. It has an exponent of 3 there, and that's not okay for it. If it's a linear function, it can't have that exponent. The next one is a yes, just in a different order, but we do have an m of 7 and a b of 4. So it is, there's our slope 7, there's our intercept 4. On the next one, number 4, and you can pause if you want to and try these last 3 if you think you've got it, and then check. Otherwise you can keep going, and this next one is a no. Remember how we said we can't have that variable in the denominator spot? So the expression includes division by the variable, which is not okay. Make that a lot smaller. And then the next one, number 5. That one is a no because it's got a square root. So can't be written as your y equals mx plus b form when it's got that square root. Excuse me. And then lastly, number 6. And number 6 is a yes. Tickle. And our slope is, for m, 2/3, and then our b is 5. Example 2, we have a meteorology example of linear function here. So on the Celsius scale, normal body temperature is 37 degrees Celsius. What is it in degrees Fahrenheit? So we're just going to go ahead and plug in our 37 in for C. So this would look like F of, and then instead of our C we're plugging in 37 equals 1.8, and replacing the C with a 37 plus 32. So we're going to go ahead and simplify. So what is F of 37? Well, we take the multiplication first, and then we add the 32. So 98.6 degrees Fahrenheit. Next example, we have, go in the other direction. So here's our how many degrees Fahrenheit if is equal to 1 degree Celsius. So for this example, it looks like we are having 100 degrees Celsius. That looks more like a degrees. And that is equal to 180 degrees Fahrenheit. So if we are trying to get 1 degree, we would undo this 100 by division. And we would divide both sides by 100. And divide by 100. And that would make 1 degree over here on the left, Celsius, equal to 1.8 degrees Fahrenheit. So how many Fahrenheit degrees equals 1 Celsius degree? 1.8. Standard form. So standard form is written in, think of ABC. So A goes with our X, B goes with our Y, C is our constant, or just our number. So what we want are integers with the greatest common factor of 1. So like you can't divide every single term by a same number to reduce it. So they should all be kind of in reduced form. The other important thing is that A, our front number, has to be greater than or equal to 0. So it can't be negative, and it has to be a whole number. So, or it can't be equal to 0, it has to be greater than 0. So these two numbers, A and B, have to be greater than 0, but A has to be that positive whole number. So what we're going to do is get it in that form, move things around. As long as that number that's with our X is a positive whole number, we can just move those things around. So taking a look at number 1, we want to get the X with the Y. So what we would do is we would just subtract 3x. But when I do that, I have negative 3x plus y equals negative 9. And remember, I can't have that front number being a negative. So we're going to divide or multiply both sides by negative 1. And all that does is just change every sign. So now it's a positive 3x, it's a negative y, and it's a negative 9. So now my front number, my A, is greater than 0. And it's positive. We're good. All right, trying the next one. You can move things around because our number that's with that, even though it's negative, we could move it to the other side, then move the 6 over. That would work. Or move the y and then change the negatives. There's multiple ways to do it. So let's go ahead and just add our 8x. Add our 8x. So we have 0 equals 8x, put that first, plus 9y minus 6. So now the only thing that needs to move is our constant, our c, and it's going to move over here by adding 6. So writing our a first would be an 8x, and then our 9y still on that side, equals, and on the other side is our 6. And there it is in standard form. ax plus by equals 6. All right, last thing we're going to talk about is y-intercept and x-intercept. And how we find those intercepts, or where they're touching that x and y axis, is we plug in 0. So what is it? Well, it's a point where the graph crosses the y-axis. And how we find that is to substitute 0 in for x and solve. So if we're looking for a y value, we plug in 0 for the one that we're not looking for. And for our x-intercept, that's just where it's going to touch that x-axis. And we do the same thing, only this time we're substituting 0 in for y. We'll change our colors there. All right, so let's practice. Here is our equation that we're going to graph. We want to find the x and the y-intercept. So let's substitute 0 in for x and solve, and then we'll substitute 0 in for y and solve. So what that would look like, let's use green, would be just to take our equation and plug in 0 for x. And now we solve. So here's 0. I'm just going to cross it out. We have y minus 4 equals 0. And we add 4. So one of our points, if y equals 4, when x is 0, one of our coordinates is 0, 4. And we can go over to 0 and go up 4, and there's our y-intercept. And then we do it again, but this time we plug in 0 for our y value. And we have negative 2x minus 4 equals 0, and we just solve. Negative 2x equals 4. So x equals negative 2, and when y equals 0. So we go to negative 2 on our x-axis, and we don't go up any, and we can now draw our line. And we have graphed that equation. Go ahead and write any questions that you have in the summary section and be ready to ask those when I see you in class.